Okay, this won't take too long. Unit 7, section 2 is really a continuation of yesterday. Now we're just going to add some letters. So instead of just simplifying numerical, we're going to simplify algebraic radical expressions. Okay, so the only difference now is that we're going to add some letters. So I'm just going to do 3 examples with you, and hopefully that'll be enough to get you going. If not, you can always check with me on Google Meets. Okay, so number 1, a square root of 72, x to the 3rd. Now I'm going to stop writing out the prime factor tree. You can still write it out if you need to, but this one, 72, is a big one. We get 2 times 2 times 3 times 2 times 3, and then x to the 3rd can be written x times x times x. And now we do exactly what we did yesterday, is we pull out our pairs to escape our radical prison. So 2 2's can come out. Remember, something horrible happens, and we have a 2 out here. Now they don't have to be next to each other to escape. So the 3 and this 3 are twins, so they can escape. They come out together. Of course, we all know the story, and one of them gets out and the other one, something happens to it. Okay, and then we have x's that can also escape. So we have 2 x's that could be paired up, and they can escape. Okay, well, x times x isn't 2x. So think about that as we're going through this. So we can pull out an x, and then left behind in my square root prison is a 2 and an x. So 2x is left behind. And then we multiply what comes on the outside. So that's going to be 6x root 2x. And that's going to be our final answer there. Okay? Okay, the next thing we're going to do is the same type of problem, but this time we'll have a visitor waiting on the outside. So number 2 is going to be 4 root 27 x squared y. So remember, the 4 is just on the outside, kind of waiting around for our escapees. Maybe he's in cahoots, I don't know. 27 prime factors to 3 times 3 times 3. Then we have an x times x, and we also have a y. So then we start looking for our pairs. Now the 4 is still just kind of hanging out front. Okay, the 3's escape. One of them gets out, the other one doesn't. And then one of the x's also gets out. Well, a pair of x's, and only one of them makes it out. And then left behind, we have 3 and a y. So our final answer is going to be 12x root 3y. Okay, that's our simplified radical expression. We're not really getting an answer. We're not getting x equals. All we're doing is simplifying an expression. Okay, now this last one, I just wanted to show you a really big one. Okay, I don't think any on your homework are going to be this big, but if you can do this one, you got it under control. Okay, so -3 root 12,600 x to the 3rd y squared z to the 5th. Now probably the hardest part of this is going to be to prime factor it. I'm going to run out of room, so I'm going to write underneath. Okay, so I have a -3. Oh, I better back it up a little. -3 square root, and our prime factor is 2 times 2 times 2 times 3 times 3 times 5 times 5 times 7. We have 3 x's, 2 y's, and I still don't have enough room for all my z's because there's 5 of them. Okay, so these are all here. All right, you're not going to get one this big, but I just wanted you to see that no matter how big the problem is, once you get past the prime factorization, it's really always just the same. 3 is kind of hanging out front. We're going to look for some pairs. Well, there's a pair of 2's. Come out. Something happens. Only one of them makes out. We have a pair of 3's in here, so that can jump out. Okay. We have a pair of 5's in there. Okay, out come the 5's. And we have let's see, we have some x's in there that can come out. So let's look for our x's. We have a set of x's, so they come out. We have a set of y's that can come out. I'm running out of colors. And then we have two sets of z's. So, let's do yellow. A z here and a z here. So that means we have this z comes out and this z comes out. And then we got to go carefully back and see what we're left with. And what we're left with, I'm just going to put a circle around them. We have a 2 left, a 7 is left behind, an x is left behind, and a z is left behind. So 2 times 7 times x times z. Now it's just a matter of simplifying. Negative 3 times 2 times 3 times 5 is going to be negative 90. X doesn't have anything to put with it, and a y. And then z times z is z squared. You can put the dots between the letters, you don't have to. And then inside we have 14x z. So it's really the same process. It's just a lot more numbers. The hardest part with these big things is not losing a number somewhere, forgetting a z that was left behind or something like that. So just be careful. If you want to color code it, color code it. I'm usually a big fan of color coding. And see what you can do with the homework.